Hello and welcome back. Further maths today, we're going to be looking at a little bit of polar coordinates. Just very simple problem. We're going to change this polar equation into Cartesian form. It's a question I wrote very recently, and I will put in one of my papers. I think that's quite it's a little bit involved, but it's not actually enrichment. It's probably if you're following my usual starage in exam questions, 4/4.5 stars if you want, probably pushing it a little bit. And the same to us, okay, write it in Cartesian and write your answer in the form some function of x and y is equal to 0. So basically put all the Cartesian bits on the left. Okay, so of course we need to know for something like this, transformation equations for polars. And the usual stuff is, of course, we need to know x squared plus y squared is equal to r squared. X is r cos theta, y is equal to r sine theta. And I'm not going to write the fourth equation because we very rarely need it. Okay, what do we do there? So r is equal to, well, quite obviously, we can change the cos theta, the sine theta. We can even change the cos squared of theta. This sine of 2 theta does not look good, so it makes sense to actually write its equivalent using trig identities. So there's my cos squared of theta. There's my 2 sine theta cos theta. That's a standard identity for the sine of 2 theta. On the top, no major changes. Cos theta plus sine theta. What I'm going to do with this one, is it useful to leave it as a 1, or can I do something else which might be useful? I guess perhaps I could leave it. I've never really tried it to leave it in there. Maybe I should see if I can get the same answer. But this bit here is special. Of course, it's coming from this identity, but this can actually complete a square. And this 1 can produce the missing item there. So let me just expand it and say plus sine squared theta. Where'd that come from? Because, of course, I got another cos squared theta. That's my 1. But in this expression, in this denominator, okay, cos squared theta plus sine squared theta plus 2 sine theta cos theta is a perfect bracket, of course. Squared is the cos of theta plus the sine theta all squared. It's exactly the same thing I go on the top. It'd be nice if I could cancel it, but unfortunately I've got this cos squared theta in there. Okay, still, nevertheless, we're going to continue with this. So r is equal to, on the denominator, I'm going to have this squared bracket, cos theta plus sine theta all squared. Let's not forget that spare cos squared plus cos squared theta. It'd be nice if it was a difference of squares, but it's not, unfortunately. And on the top, cos theta plus sine theta. Okay, have I made progress? In all honesty, when I'm looking at the original and this, it's a minimal progress. I'm just actually wondering right now, was that really worth it? Or shall I would have, after I wrote my 2 sine theta, I should have gone up here and just substitute my equations. I've done it this way now, so we'll continue with this. So let's put now what these things are in Cartesian. I'm gonna leave this r there. It's a good thing to leave it, because we might create r squared eventually by timesing by another r. So leave this one, doesn't bother us where it is, until we see what's going to happen on the right hand side. So on the denominator, I'm going to have, of course, using the equation x is equal to r cos theta divided by your r, x over r plus y over r, that's my sine, all squared, plus I've got a cos squared, so that's going to be an x squared over r squared. And on the numerator, I'm going to have just this bit here. That's my cos plus sine, but not squared. So x over r plus y over r. So some r's appeared in there, so that's why I left that. I just hope maybe I can create an r squared. Let's make some room and also give ourselves a bit of thinking time. So as to what is our next move. So I don't want to quite multiply this bracket. I mean, I actually just put into a bracket in there. So what I'll do instead, I will in fact factorize out of this bracket a term 1 over r. But of course the bracket is squared, so when it comes out, it's going to be 1 over r squared. So what we will leave inside the bracket is x plus y all squared plus x over r squared, because I have the same factor now out of r squared on the bottom. And on the top, maybe I'll do exactly the same. I will actually write 1 over r and write this as x plus y. Okay, what's my next step? Is to multiply top and bottom of the fraction on the right hand side by r squared. Okay, no, I'm not timesing both sides of the equation, by the way. So let's me just lose this line first of all, so it doesn't distract us. R is equal to multiplying this by r squared on the denominator will create simply x plus y all squared. Multiplying this term by r squared, there it will leave you another x squared. And multiplying this term here by r squared, it will create, because we put an r squared there, it will cancel this, but it will still leave us with an r on the numerator. So it's going to be r x plus y. What do we do next? Well, now a different operation. I can divide both sides of this equation by r. So this will give me 1, divide by r, x plus y over x plus y all squared plus x squared. In fact, I think this is probably a 4 star. It's not actually a 4.5, just coming to think of it. It's not really that hard. And also I begin to think bracketing in the beginning the cos squared plus another sine squared from that. It looks fanciful, but I don't think it makes that much difference. The elimination has been done, but because of how they want the answer, I just need to do a bit of tedious algebra. So times this across, x plus y all squared is, plus another x squared from this line here is equal to x plus y. And we can actually, all it says, just shove things to one side. I could leave it as a bracket like this without expanding it. X plus y all squared plus another x squared minus x minus y is equal to 0. And as far as the question was just saying, just give your answer in this particular form. We are done. If you want, you can actually expand this bracket. We're going to get an x squared from here. With this x squared, it's going to give us 2x squared. We're going to get a y squared as well from this squaring. We're going to get a cross term. So we're going to get a 2xy, and then of course minus x minus y. It hardly makes a difference whether you have this line here or this line here. The question is done. Just a little quick question on polar coordinates and transforming from polar to Cartesian. Who's laughing now?